So homework questions 13.1, this is 33. And so it asks you to find a vector equation for the line, and then they tell you that this line is the line of intersection between these two vectors. I mean, these two planes. So you have two planes in space. If you just think, here's a plane, right? Here's another plane. And you want to find the line of intersection, right? So two planes could be parallel, but if they intersect, they're going to intersect in some line, right? And so we haven't done one of these. This is a good question to ask. But let's just think about this. We got some plane here, some plane here. I'm looking sort of down the planes, okay? So assume you're looking down those planes. What sort of things can you read off of the equation of a plane real easily? Or what is the main thing? It's the normal vector, right? You can pop the normal vector off of an equation of a plane. You can find n1. What's the normal vector for that top plane?
1 minus 2, 1.
So it's 1 minus 2, 1. And let's just assume this one looks like this. What's the normal vector for that second plane?
Minus 1.
Minus 1, 1, -3. Does that make sense? And so now, again, I've made no effort to really draw these in any sort of form. I'm just thinking I have two planes like this. I got normal vectors sticking off those planes. I want a line, basically my line's coming out of the board, right? If I got two vectors in the board, how do I come up with a vector that's poking out of the board? Just their cross product, right? So you can take the cross product of those two vectors, and that should point in the direction of your line. Does that make sense? So I'll just say direction of the line, and let's just call it V bar, and so I'll get the N1 cross N2, or N2 cross N1, doesn't make a difference. One of them will point this way, one will point in, right? Point out or in. So ijk, so that's 1, -2, 1, -1, 1, -3. So what do we get? 6 minus 1, so 5. -3 minus -1, so -2, but it's negative, so 2. And then 1 minus 2, -1, I think. Does that look okay? All right, so that's your direction for, you're supposed to come up with an equation of a line. So what things do you need to get the equation of a line? You need the direction, and you also need no. So I got a line and it points this way. Right? So assume my arm's staying still. That's the same vector, right? But I'm getting different lines. What's the other thing I need?
A point.
A starting point, right? So we need a point of intersection. So let me rewrite V here. So we came up with 5, 2, -1, and then find a point of intersection. Okay, and so we have here So we have this plane, right, or these two planes, and we want to find one point that's common to them. Now, you have infinitely many points common to them, right? There's a line full of intersections, or a line of intersections, so there's infinitely many points. And so you could come up with the formula. You actually could find you could find the line of intersection just using these without even doing what I did here, but we're really trying to focus on this idea of a normal line. But the point is that if you got some line through space, it almost always will intersect one of the coordinate planes, right? So it'll almost always intersect the xy plane. You're at the xy plane when z is 0. And so you can just set z z equal to 0 in both of those. Now, if this fails, that just means you picked you should pick one of the other variables, because you could have had a horizontal line like this, right, that never intersects the plane. But if you have that, it's going to intersect the y-axis or the x-axis, or sorry, the yz plane or the xz plane, right? And so if you run through all three of these, you'll get one of them that works, and it almost always works for all of them. So you just pick one of them. I picked that one somewhat arbitrarily. I always just go with the z for whatever reason, but it doesn't matter. You can pick a different value. Does that make sense?
Yeah.
And now we just have a system of two equations, two unknowns, so solve that however you want. This one, you can just add the two equations and you end up with what?
X equals to 4, so negative 4.
Not x, right?
Minus y.
If
Minus
you
one.
add them, that's gone.
Oh,
And then
Minus
minus
one.
y is 4, so y is negative 4, and then x is y, right? From this equation, and so it's also negative 4. Does that make sense? And so our point, I'll just call it p, is negative 4, and then 0. So the line of intersection, right, is the point plus a times t, right? So our vector is the 5, 2, negative 1, and here's our point. So it's negative 4 plus 5t. That make sense?
Yeah.
Negative 4
plus 2
2t, and then 0 plus
negative 2.
negative t.
So is that possible? I pick up the different points that
Yes.
make the different answer.
Well, yeah, I mean, it's not a different answer. I mean, it's the same line, but it'll look different. But yeah, if you had set, right, if you set y equal to 0 instead, right, then you'd get x minus, or x plus z
Okay.
is 4, right, negative x minus 3z is 0. And so if you add these two, you get negative 2z is 4, right? So your z would be negative 2. And so you'll end up with the point, in this case, 0, negative 2, and then if z is negative 2, x had to be 6, right? You get there, and so you'd have that point, and so that would go in instead.
Okay.
And so it's just like with, right, point slope form, if you remember, for a line, right? You have all different forms, they really correspond to the same line, but you're just sort of at a different place. And you also could have, right, if you had done n2 cross n1, you would have got negative 5, negative 2, 1, so you'd have the vector pointing the opposite direction, but they correspond to the same lines.
Okay.
Okay, any other questions? And I mean, I was picking 0 here. This was, I mean, you could have picked, let's just let y equal 5, and that should give you another point as well, right? You can almost pick any point unless you're, like I said, unless you have a specifically bad line that's, you know, not crossing some place. Okay, anything else on this one? So 39. So let's see here. 39 says, find an equation of the plane, and so they want the plane that contains the lines, and so let me just write out the lines. So this time, what they're saying, right, is you have two different lines, and there's some plane that contains both of them. So those lines must intersect somewhere. We actually don't need to find out where they intersect. All you need to think is you got two lines, right? The direction of one of these lines, let me call it B1, is 2, negative 3, 1, right, from the top line. The direction of your other line, again, I'm not really drawing anything in the right positions. I'm just saying I got two arbitrary lines. So I got one direction I can read off of the 1. The other one is here, what, 3, negative 1, 2, right? I'm just reading the t coefficients if instead of just 2t, this was 5 plus 2t, you'd still just read off the 2, right? So you end up with that, and so now, right, two lines in space should form a plane, right? And so now, what's the normal vector for that plane? You got a line here, a line here. You want a line perpendicular to those two lines, and so it's again that cross product. So your normal vector is just the cross product of those two vectors. Does that make sense? And so what do we get? -1 minus -6, right? So plus 6, so 5. And then we have 3 minus 4.
1.
So -1, but then it's already negative, so 1. And then finally -9 plus 2, right? So -7. Okay. All right, so we end up, I forgot to put my IJK up there, right? Again, if you have some technique that you use, just keep using it. I just do it in my head, so. But anyways, we end up with that. And then what else do we need? So for a plane, again, we need a direction. This time it's a normal direction, right? And then we need a point. And so what's the point? There's an easy one.
Can you just,
Intersection point?
Well, you could find the intersection point. You don't actually have to though, right? All you need is some point, and we're told the whole lines are in the plane, right? You can pick any point on the line. So what's a point?
you know, 1? Can you just pick?
Well, you could let t equal 1, or you could even do 0, right? If you let t be 0, that point is on that line. What point is that, or what vector is that? 0, 0, 0, right? So that point is on your plane. So, and notice this one gives you the same point, 0, 0, 0. So their intersection is actually there, but you could have done 1 as well, right? That point's on there, which is 2, -3, 1. It doesn't really matter. You just pick any arbitrary point on the line. You could let t be 1 billion, right? That would give you another point on the line. And then you're just doing the equation of the plane, normal to this, and through this, it's written as a vector here, but we think of it as the corresponding point, right? So what's that plane look like? 5, not t, it's a plane, right? 5 times x minus 0 plus 1 times y minus 0 minus 7 times z minus 0 equals 0, or you could have replaced the zeros with 2, -3, 1, right? Or any other point. And all of them are perfectly acceptable answers. And so maybe even here, again, right? So what is this? This is 5x plus y minus 7z equals 0, right? Notice that if instead you use that, so this is the answer. Either one of these would be fine. You don't have to do more work than this. But suppose you pick that other value, you get what? -2 y minus -3, right? So +3. And then -7 times z minus 1. So again, on the surface, these look like different answers, but if you multiplied this all out, you get 5x plus y minus 7z, right? And then what do you get? You get -10 plus 3 minus -7. So you get 0 again, right? And so they turn out to be the same thing even though they look different. And so that's what I was saying before with the lines. Even though they look different, they're giving you that same line. Okay, any other questions out of 13.1?